they don't show you. They say this guy failed already. You don't know Ohm's law, you fail. Okay. So they'll get the next guy. So remember Ohm's law, V equal IR. It was invented by George Ohm. Okay. Let me show you George Ohm. This is George Ohm. Okay, he invented V equal IR. He's a German mathematician who invented the Ohm's law. Okay, this other guy here is Henry, who is very significant in electrical. But let me go to the beginning, the first peoples. Okay, William Gilbert invented the word electric. Okay, from the great word electron. So historically, the 1800s, and the next thing was a Dutch guy invented the Leyden jar, which was the first capacitor. Okay, so the capacitor was the first electrical device invented. Okay, and then later they want to keep the charge for a long time. They invented the battery. Okay, so the next thing was Benjamin Franklin. He used a Leyden jar to prove that lightning was actually electrical, because before people didn't know what is electric, what it was lightning. Okay, so he also invented the the lightning conductor, which basically you put a copper rod up your house. You know, now they sell it as strips of copper, quite expensive now. You just put a copper out as one of the highest point of your house, and you just strike them. And electricity has a simple brain. Okay, electricity just want to go to Earth. Okay, so all lightnings, they just want to go to Earth. Why they want to go to Earth? Because you see, Earth is basically silicon dioxide. Okay, silicon and oxygens are both non-metals. Okay, so as you know from chemistry, non-metals, they like to take in extra electrons. Okay, like oxygen, they like to take in 2 extra electrons. Okay, so non-metals like to take in more electrons. So when lightning from the clouds, which are electrons, they come down, the Earth wants to absorb them. Okay, so what happened to our electric system is also the same thing. See, our power is mostly from Bakun and Murum. Okay, that's most of our power is from there. So you can imagine like the power is rushing out of Bakun and Murum and going all through Sarawak. But what's the end point? The end point is your substation neutral. Okay, the substation neutral is the end point. Okay, on the way it powers your lights, your TV, your radios, all this. Okay, the end point is the Earth in your substation neutral. Okay, okay, the substation neutral in Kuching, you have about 20 to 30 earth rods. Okay, the house is only one earth rod in most cases in Kuching. Okay, in Cebu, I work in Cebu in the university in Cebu. A typical substation in Cebu need 40 earth rod. Kuching is around 20, 30 is okay. Why Cebu need more? And Cebu is much wetter than Kuching. Okay, because the pure water doesn't conduct electricity, and Cebu's water is mostly without salt, because you know it's very hard for the seawater to reach Cebu. It's too far. Okay, so even Kuching, we have river which is fresh water, but sometimes you know the seawater can come up to Kuching, and then Kuching is still close enough to the ocean such that our soil has a lot of salt, so the water around here is salty. Yeah, so we just need about 20 to 30 earth rod for a substation. Cebu is all fresh water, so they need 40 earth rod. Okay, so there's an instrument to measure all this. It's called the earth resistance meter. Let me show you. Okay, I never use Microsoft Teams much, but okay. Wow. Okay. Now wait a minute. Wow, what is this? Okay, I got it. I don't see. Okay, now I got it. Okay. Resistance meter. Okay. This is a resistance meter. This is a British brand, but in Malaysia, actually, especially in Sarawak, most contractors use this brand. It's a Shoe brand. Okay. I did ask Cisco why you prefer Shoe. Okay. They told me. Actually, they have a list of brands. It's not just Shoe. Wait a minute. Sorry. Just a moment. Okay. So I did ask the Cisco staff why they prefer Shoe, which is a Japanese brand. They told me this they have a list of brand, but the cheapest that is good quality is Shoe. So all contractors in Sarawak buy a lot of equipment. Okay. So that is just one of them. Okay. 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 Okay, so this is the so this is how you do it. Basically, okay, the yellow and green wire. The whole thing comes as one set. Okay, there's two these are tees. Silvery tees. It should be copper plated with tin. Okay, that's one thing. So you can buy the red roll. You don't have a method. Each time you take out this instrument, it's a big mess with all this long wire here and there. So what I do is I put this on a fishing line drum. Okay. Okay. So you can buy red drum, yellow drum, so I keep it neatly in the equipment. My other equipment, all I can put in a separate bag. There's about equipment we use, to stretch. Rolled up now, man. You just click it to the up rod, and then this two you stretch away. So this is how it is. See, we stretch it all the way, and then we clip this point. And the green and yellow wire, the red and yellow wire. This one doesn't look yellow, but anyway, it is stretched all the way. And this is the earth rod. We don't. Yeah, this is the earth rod. How it like? Yeah. So here is the same thing. The red wire is already there, and he's pulling the yellow wire. The green wire is already at the earth rod. Okay. So we'll come back, go to the machine and press, and it says 2 ohms because it's times 1. So it's 2 ohms. So we did some more improvement in the earthing, and then we got it less than 1 ohm because it's telecommunication equipment systems. We need less than 1 ohm. In fact, right now that's the standard for all electric power stations, also less than 1 ohm. The house you can go for 100. Okay, so there are 3 standards for substations and old telcos is less than 1 ohm. For Cisco poles, all those tiangs, you need less than 10. And for homes, you need less than 100 ohm. So there's okay, so okay, so we measured this to be less than 1 ohm. It's a lot of earth rod. The telco towers need a lot of earth rods. Okay, because you see telcos, they're dealing with ones and zeros. Every year it gets more and more tiny. So a bit of noise from various sources can disturb your signal. So that's why they need the best thing possible. Okay. Huh? So I use the house one. Wait, how to get up here? Yeah, correct. Okay. Get back. Okay, got it. Okay, so can you check? Okay, so okay, for earth rod, it's becoming more and more important. Okay, the earth rod, because equipments are getting more and more sensitive. So more and more, I think you need to weld. You see the earth wire to the earth rod. The standard way is Catwell, and this is the meaning of Catwell. Basically, you put some gunpowder inside there. They call it black powder, just actually it's gunpowder. Okay, and then you're supposed to hold it. Okay, you're supposed to hold this tube bloating, but nobody did to hold it in Malaysia. Because if you don't hold it, it will just topple over. See, so nobody did to hold it. So they try to put some bricks and straighten it up, and then you use a oxygen metal cutter to blow here, and then you just explode, and it will melt this green wire to the earth rod. Okay, so that's the proper way of joining earth cable to earth rod. In houses, they just use the earth clip, which is kind of totally useless because it's totally corroded. The copper is all black in color. Black means copper oxide. Okay, and remember, all metal oxides are insulators. Okay, so in copper is black. For aluminum is white. Okay, metal oxides are some of the best insulators around. Okay, metals are good conductors. Metal oxides are some of the best insulators around. Okay. Okay, so I don't recommend this because I've seen a lot of people using this. One thing is so expensive. Even the shop, there's only one shop in Kuching that sells this thing. And he says it's a big problem selling it because, it's basically gunpowder in the shop. And if it explodes, all his stock is gone and he has to pay a whole lot of stuff, even to the neighbor shops and all that, and there'll be a big police case and all that. I see. So I don't recommend this. I prefer, but the problem is that all work orders, when you get a contract, you get a work order. All work orders states Catwell. I don't know why. Consultant engineers just write the word Catwell there. Okay, but I prefer this one. Okay, this is the gunpowder. It's called black powder. Okay, so this is how it works. You just put a gunpowder there, and then when it explodes, it just melts the two copper together. Or sometimes it's the copper and the earth rod. Okay. So there are various, you can do a T-joint, or can join it to the earth rod, various molds. You can buy different molds. But I highly don't recommend this because one guy have been, this is the formula for it, you see. One guy does this, you see. It is so much better. All you need is one tank of oxygen, one tank of acetylene, and this is the copper welding rod, okay, and then you just weld it. You can easily manually handle it, and you can, different shapes, different conditions, T-joint, whatever joint you want, you can easily manually handle it. See, whereas the gunpowder one, you have to run away. Most people are scared of it. I don't blame them. I would run away also, because what if someone made a gunpowder too powerful? I wouldn't dare to hold that thing. Okay. So earthing is becoming very important, and these are some of the expensive earth rod. That is, Thai Poly. It is a brand in Malaysia, which if you have a serious contract like a telco contract, you must use Thai Poly. You cannot use any other earth rod. Earth rods are actually iron right now. Okay, plated with copper. Nobody sells the pure copper. Even this Thai Poly is not copper. Okay, it is steel plated with copper. At least they use steel. Most earth rod you buy from the electrical shop is iron plated with copper. Okay, and you must buy from electrical shops. You cannot get from these cheap shops as a contract. And I made the mistake of doing that. Just go to a normal shop, get a socket point. Because someone asked me to repair something in Bau, Kedai Kopi, and I tell you, this normal shops thing, you turn the screw turn forever, and then I got to really work very hard to repair that thing. Finally, I decided to just throw it away and just get repair the old thing. Okay, so you must get from electrical shop. And there are very few electrical shops in Kuching. I go to Crown Engineering. For me, I go practically almost all the time to Crown only. To get conduits, I go to another shop called EEC in Ellis Road. Crown Engineering is in Pedungan. I get practically all my things there because I trust the guy to give me the right things. You're a contractor. You go and do a job, and then it fail. You cannot say, no, it's not my problem. The supplier sold me the wrong thing. No, you cannot say like that. You're a contractor. One of the job of a contractor is to know who sells the right stuff, and not only locally. See, locally, I'm telling you, is Crown and EEC sells like conduits. All those I get from EEC there are very few shops in Kuching that I get from. Cebu, I get from only one shop. Something Brook, something lah. Okay, I know where it is, but I forgot the name. Miri, Sarawak Electrical is okay. So there are only a few shops I go to. Electrical contractors are all like that. Yeah, another good one is PowerPoint Electrical, Jalan Bangkok. That's a good quality. There are very few who sell really good quality. Okay, the good quality ones are mostly suppliers of Cisco. Okay, so if you find out they are supplier of Cisco, then you know the good quality supplier. Okay. Okay, so earth rod. This is a spec. What goes into the ground, the wire size going into the ground must follow the incoming size. If your life is 1 to 16, is 1 to 1. That means 16 must go to the ground. Okay, so your in this one is 25. If 25 coming in, 16 can go to the ground. But if greater than 35 mm square, half the size of the phase conductor. This is a IEE standard now. Okay, actually now it's IET, right? Okay. Okay. How do you improve the earthing? You must drill a hole first. That's the best way. Okay, you want to improve. If you don't need to improve, okay. Like Kuching in most places is quite okay. Like in Cebu, sometimes you find problem or uphill. Like mountainous areas like Singai. Singai is a bit mountainous, so hilly areas is very hard to get a proper good earthing. Okay, so the best thing is to drill a hole. How do you drill a hole? This is a machine. Okay, you must buy this machine. I found out this one. I checked in Amazon. It's 169. You drill a hole, then you put the earth rod in the center and stuff it with fine sand. Why you need fine sand? You see, the earth rod is being held by the sand, right? Okay, if it's 10 ohm resistor and another 10 ohm resistor, the 1/10 or plus 1/10, 1 over RT is equal to 1/10 plus 1/10. You get RT is 5, right? You put 4 resistors, 1/10, 1/10, 1/10, 1/10. 1 over RT is okay. The RT will be about 2.5. Basically, the more resistors in parallel, the lower the ohms, right? So the finer the sand touching the earth rod, the lower the ohms. So where do you get fine sand? I did a project in Barrio. Barrio, the sand is almost like powder, okay, like rice powder. Okay, that's best. You can import the sand from Barrio, and then charcoal and burn wood is very good because, but you don't put salt. Most contractors they put salt just to get a reading, and then the salt get washed away in the rain. Okay, that's cheating. Okay, in exam papers, like you go to take a CESCO exam, don't go and I put salt. You'll fail. Okay, that's a way to cheat. Okay. Burn wood is okay. You can burn a lot of wood and stuff the hole with burn wood because burn wood doesn't get washed away so much by rain. Fine sand also won't move away too much. So these are good stuff. And then you hammer it as much as possible. Why? Because you get more and more resistors in parallel. Okay. The more resistors in parallel touching the earth rod, the lower the ohms. Okay. So here's another one. 359 is USD, so you just times 4 lah. This one is only 169 times 4. Okay. So this is what I'm telling you. See, the more resistors. This one I use Excel to do it. 1 sand particle silicon dioxide is about 200 kilo ohms. So I use Excel 450 sand particles touching the earth rod. The resistance only 444. Okay, note this. 1 sand is 200 kilo ohms. Okay, and 450 sand particles, the ohm just reduced to 444. So you got billions of sand particles, the ohms just goes down very low. Okay. Okay, so there are other systems like this, to reduce the earth resistance. Okay. 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 Oh. Okay, what's this? How to go to my another PowerPoint? Oh yeah, okay, got it. Okay, let me go back to this one. So Benjamin Franklin discovered the earth rod. So remember, all electrons just love the earth, and the earth is just an absorber of electrons. So the whole power system of Bakun just goes to earth. It's not like a battery, right? You have a battery, it goes to bulb and comes back to, from positive to negative, right? But for electric system, it was a discovery. They discovered they can do this because the first use of electricity was for telegraph. Okay, so a telegraph, was invented by Samuel Morse. You have a solenoid and you have a metal on top, and then when you energize it, the solenoid becomes a magnet. Okay, so they found out, hey, this can be used for telecommunication. Let's put it far away. Oh, still can. Let's put it, okay, Kuching, you put it in Syrian. But you have a simple, okay, a battery goes to a solenoid, comes back, okay, and that becomes a solenoid, okay. But okay, let's put it in Syrian. From Kuching, you can communicate to Syrian. But problem, you need two wires, negative and positive. And then one guy said, hey, why don't you just put the negative in Kuching? Sorry, the positive in Kuching, and then the negative just go to the earth, and it works. So that's why they call single wire earth return. So the whole electric system is single wire earth return. From Bakun is coming out, there's no wire going back to Bakun. Okay, it's just going to the substation neutral. That's where it ends up. All electrons in Sarawak from CESCO basically ends up in the substation neutral. So you can look at it this way: from Bakun, it's just rushing out. It's powering the whole Sarawak, powering the homes, factories, schools. Okay, and what's it searching for? Substation neutral. Okay, Swinburne has a substation neutral. UCT has a substation neutral. All this whole housing estate as substation neutral is just adding up there. In between, it powers everything in Sarawak. Okay. Okay. So Benjamin Franklin made one mistake. Okay. He conceived that current flow is this way, but later they found out what is electricity is actually electron flow. Okay. They found out it's wrong. Benjamin Franklin made a mistake. So it's the opposite direction. I said, now mind, because the books will be too difficult to change. Those days books are quite expensive. Let's leave it that way. So the whole world living in current flow, which is opposite of what's the real thing. The real thing is actually electron flow. Okay. But if you do calculations, everything upside down, you still get the same answer. So that's why our circuit theorems still work. Okay. So they gave a definition for current flow as flow holes. How does that happen? You look at this one. This electron from here goes here, so there's a hole here. So this electron fill up that hole. The hole is here. So this electron fill up that hole. The hole is here. So the hole goes this way. Electron goes this way. Okay. So that's the definition of current flow. So the next famous guy was this Gavani, who actually believed that the electricity is the thing that gives life to everything on Earth, okay, to humans and animals. So because he used one metal and another metal and put a frog leg in between, and he got electricity. So he said, hey, electricity must be coming from a frog leg. And then this guy, Volta, was from another group of people they call the Enlightenment, okay. He said, no, he got to be wrong. So he was playing around those days, no TV. He was playing 2 coins. He don't know what to do with the 2 coins. And he put it on his tongue. He felt a shock. Those days, people knew shock, but they don't know what's electricity too much. He felt shocked because there's 2 different metals. So he tried to simulate what he did. 2 different coins. He found out they're different metals, and then his tongue. So he get a cloth. Put a bit of sulfuric acid. So one coin, cloth with sulfuric acid, another coin, and cloth with sulfuric acid, another coin. So he made a pile, so the voltaic pile. Okay. So he invented a voltaic pile. Okay. So, and then he found out electricity was continuous. No one ever saw continuous current in those days. Electricity was always a show, to entertain the rich people. On a wine glass, they've got a shock, it was always a spark till that time, but his one never stopped. And he said, hey, this is just like the river. It's a flow. It's a current flow, like a river. So he came up with the word current flow. Okay, Volta came up with the word current flow. Okay, current is basically from Volta. Okay, because it's basically like a current of the river. Okay. So he invented a battery and he became super rich and famous. All the big royalty of Europe started inviting him all over Europe, and he became rich. And this other guy died in poverty, Luigi Gavani, because he was wrong. Okay. Then you get all these other guys, this Coulomb, we invented the unit of electric charge is Coulomb, and then Oersted and Ampere was very important because he found out that electrons behave as a magnet, because a compass, you have a wire with a current, a compass can get deflected. Okay, so basically electrons are magnets. Okay, now you type in Google, they'll tell you electrons are magnets. Okay, they're tiny little magnets. Okay, then the biggest guy in all honesty was this guy, Michael Faraday, because he invented the electric motor, electric generator, and transformer, the three main thing of electric supply today. Okay, so but he was, very low education, probably primary 6 or something, and then he went to a bookmaking factory, and he read all the books in the factory, and then he became very good. The chief scientist of England called him in, and he became even better than a chief scientist. Okay, he started doing experiments and all that. In the end, Queen Victoria wanted to give him a sir. He said, "No, I need to live and die as a simple man," something like that. He said, "lah." Okay, so you don't have a sir. Okay, so okay, this was his first motor. Okay, he put a battery. The bottle is just to hold this wire, and then he used, actually not like this, it was just a hook, and he put a permanent magnet there. He energized it, and these things are turning. So for 30-40 years, all the motors were like this, until a German guy came up with the idea of putting bearings on the side, so you get a current day motor. Okay, so this guy made the first strong electromagnet. Okay, you see, what is electromagnet? Is basically a coil of wire. Okay, so a wire, straight wire, there's no resistance. I mean, low resistance. Copper is very low, right? But if you put two wires like that, negative, positive, it will be a short circuit. Okay, the current will be very, very high. Most electric fires are due to short circuits, because V equal IR. Okay, V equal IR. So I is V over R. When you put two wires touching negative, positive, V equal I equal V over R, and the R is like 0.02, so the I jumps up to like 12,000. That's short circuit. Yeah, so most electrical fires are caused by a short circuit. Okay, but the same wire, you just coil it around and then touch, nothing happens. Nothing happens. The same wire, you just coil it around, because that coil is a load. Okay, remember, so coils are sensitive to electrical. I see some people do wiring, they put coil. That's wrong. There's resistance. Okay, so he had a problem, because when he made his first electromagnet, he just used a coil of wire, and then it became electromagnet, but it's hot. So he said, "Hey, you know what? You get a paper, okay? You put a magnet here, you put an iron here. The magnetism can flow through an insulator like paper, okay? But electrons cannot flow through paper, okay? So he said, why don't I just use a silk string and just roll it like he rolled half dead, and he got a solenoid which is rolled up, insulated with silk string. Then he got a super powerful magnet. It doesn't get hot also. Okay, so he invented the most strongest magnet of those days. And later, this guy, this was his solenoid. So this guy used the same invention to create the telegraph, which was the first use of electricity in a big scale. Especially in US, because US was a new country and they needed some invention to unite the country. So they invested heavily in telegraph, since Semmelweis was American anyway. Okay. Okay, so then the next few guys are like these guys, Weber and Fleming. Fleming did this rule, this very, very important rule. And you must have a way to remember. Don't put it like this. You must put it like a gun, like a Secret Service in America, like a gun. Then only FBI. Say F is the direction of movement of a magnet. B is the magnet's north-south, and I is a current generated. Okay, but I wrote a book. I don't want this to be F as force, because in transformer, there's no force, there's no moving parts in transformer. How can current from here go to here? The wires are not joined. You see, in transformer is AC, right? So the magnetic field, if you call this varying field density, then it works. See, varying field density. You see, like this, you get a magnet going like that. What does that wire see? At first, you see 0 magnetic field lines. Then you see, okay, say this one had 10 field lines. Okay, now you see 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so this one sees a varying field density. That's why I call this varying field density. So it's still F. Okay, so in transformer, how does it work? There's no moving parts, but it's AC. So the field density is 0, maximum field 0, maximum field 0, maximum field 0. You have varying field density. Okay, you have varying field density. The coil is a solenoid. You got a B, so you got I in the secondary coil. Okay. Another thing you need to know about electricity is skin effect. In AC, current only flows on the skin. It doesn't flow in the center in AC. How does that happen? Okay, say you got a in AC, electrons just moving back and forth. Okay, if you got a wire, okay, if you have a wire like this, electrons just moving back and forth. Okay, why does it move back and forth? You see, in Bakun, you got red phase like this. Okay, clockwise, anti-clockwise. The magnet current goes out to Sarawak, and then magnet goes down this anti-clockwise coil. It comes back from Sarawak. So effectively, in all AC wires you see in your house or overhead, the electron just going back and forth at 50 hertz. Okay. Okay. So so in AC, you imagine that electron is moving from here. Say, assume it's just one electron, and this electron has 10 magnetic field lines. You know the field lines the teacher show you in class. The teacher go and take a paper and put a magnet with iron filings. You can see the field lines. Okay, so this electron has 10 field lines. You go from here to here and back. Okay, assume it's very slow. So here you got 10. T plus 1 you got 10. T plus 2 you got 10. T plus 3 you got 10. So around here where it's maximum speed, you got a lot of field lines, and here's only 10. Here's only 10. So you got varying field density already. You got 10, a lot, and a 10. So you got varying field. You got F. You got B. Why you got B? Because electrons are magnet. Okay. So like that, you got current generated this way. Some electrons like that, so current generated this way. Some electrons like that, current generated that way. So effectively, there is current generated within the AC wire from the center going out. So it pushes all the Bakun electron also out to the outside. So current only flows on the outside. That's called skin effect. Okay. So the higher the frequency, there's more skin effect, right? In aeroplanes, you see in Cisco, they turn the generator at 50 hertz. Okay. The generator turns at 50 hertz. Okay. In aeroplane, it's 400 hertz. So there's much more skin effect. Why? Because here is 10. In aeroplane, here also 10. Okay. But here is much more because it's 400 hertz. So it's much more field lines here. Here's only 10. So you got varying field density with extra F. So you got extra I. Okay. So in aeroplanes, the current is only flowing a very thin outside. The skin effect is much more. Okay. So what they do in aeroplanes is to run the same wire in a house, they need to put maybe 3 or 4 wires because the surface area through which you can travel is only very little. In DC, it doesn't happen. Okay. Why it doesn't happen in DC? Okay, say you got a super high DC, yeah? You got a super high DC, okay? You got full of field lines here, but it's not varying. The field lines are full, but it's not varying. This needs varying. So you don't have current generation. So in DC, it uses the full surface area. So that's why HVDC is coming up in big countries. In Malaysia, there's one. Between Kedah and Thailand, there's a line which is HVDC. They use that as a standby in case Thailand lack of electricity, Malaysia supply, Semenanjung Malaysia lack of electricity, Thailand will supply. Okay. Okay. So of course, the biggest guys who really brought out the whole invention of electricity was these two guys, Edison and Tesla. Okay. Electricity would have been just a scientific experiment. but it's just this guy, basically it's Edison, okay, who brought it out to the world. Okay, and Tesla worked for him, but Tesla did most of the innovations in the electric field. Edison brought it out to the world. Okay, he also actually followed the former famous guys. He followed them. Okay, and then he made one very clever invention and exhibited it in New York. And then the New Yorkers went by, wow, very clever. But no one wanted to buy it. So he made a promise to himself: from now on, if I make something, I must sell it. So all big companies, Samsung, Apple, if they invest in something, they must be able to make a profit on it. If not, they won't even invest. I was working in Western Digital after Cisco. I buy some screws. The boss will ask me to write out, exactly how that screw, if I buy for 3 ringgit, can make 10 ringgit after 1 year. Okay, high-tech companies are run this way now. Okay, it's quite different from Cisco, which is more like a government. I don't know about now. I left Cisco some time back. A lot of corporations are run, big companies, especially like government corporations, are run not very effectively. But in high-tech company, it's very critical. Every small thing counts. We make improvements in small thing, and then once while we have meeting, oh, he made a 0.01 cent improvement. Oh, everyone clap. Okay. 0.01 cent improvement. Okay, so that's how it is in high-tech industry. Okay, so this is basically how it works. Okay, in Bakun, you got a red coil, the yellow coil, and the blue coil. Okay, so you see when the magnet passes the red coil, the red is high. When it passes the yellow coil, sorry, next it will pass this one, which is the blue anti-clockwise. So the blue anti-clockwise is high. Next one, it passes the yellow clockwise. So the yellow clockwise is high. So that's how you get our AC. Okay. So 3-phase motor runs with just red, yellow, blue. There's no neutral in 3-phase, right? So how does it run? The power between these two, you see, like this is time. At 5 milliseconds, between yellow and blue, there's this much of voltage that generates the power, okay, to move, okay. Okay. So induction motors are the biggest motor now. If you want to get into industry right now, induction motor is the using basically 50% of the world's electric energy right now. Okay. But wiring, let me show you. Cool. Oh, this is funny. Damn. Okay, wow, that's slow. Okay, for wiring, you need to draw a schematic drawings. The first thing you do in wiring is calculate your load. You do wiring. Customer wants this many bulbs, this many aircons, this many water heaters. You go and record it all down and then calculate the watt. From the total watt, you must calculate how many amps. That's why I told you vehicle IRP equal VI, some of the most important formulas. Okay, you must calculate the total amp, and from the amp, you can design what components to use, because the components are according to what amps there are. Okay, if you want, you can take a print screen of this, and then this is what contractors use the most. Okay, all these different sizes of wire for different amps. So just all the amps, the miniature circuit breaker, the different amps being used, the RCD, residual current device, isolators, cutoff fuse. Okay, so basically, for one phase meter, single phase meter for most homes in Kuching is single phase, you can only go out of 52 amps. You want more than 52 amps, you need to use three-phase meter, which is 52 to 100 amps. And then more than 100 amp, mostly in factories or like schools, like Swinburne, UCTS, you need main switchboard. Okay, so that's the spec. Okay. Yeah, so just a definition. Extra low voltage is less than 50 volts, mostly telecom, CCTV, all that. Low voltage is between 50 to 600, and then high voltage is between 600 to 3000. Extra high voltage 3000 and above. Okay. So you need schematics. I mean, let me go back to some of the biggest problem in electrical is the copper. They don't use the pure copper anymore because they mix iron inside. You know, it's all profit making. Okay, and then one of the biggest problem in electrical installation right now is this one. Okay, people screw on the plastic because they cut very little, they strip too little, and then the screw end up on the plastic. So it will work for a while, you know, maybe 1 year, and then it fail. Because I talked to the guys who are doing this every day. They said this is the biggest problem in Sarawak. Okay. Okay. And then don't ever join anything with black wires. Okay, the black wires are basically copper oxide. Okay, so like this particular machine was in Unimas, it's black. You strip it, it's still black inside. That means all corroded already, so the machine cannot work. So I just use a pen knife, scrape it off, and start working. Okay. So the way they cheat in wires is mixing with iron, or sometimes aluminum plated with copper. Okay. So you must watch out all this, and then joints. You must do proper joints. Okay. The proper joint is by soldering. Okay, you must solder joints. Okay, so what I do is this one. Okay, and this is how I do it. Okay, so you know, I use a blower like this, and then okay, so I just now hold the lead and melt it down. Okay, so that's the way to join wires. You must solder. Okay, there's no other way. I know a lot of people use this way. They crimp and then tape, which is totally wrong because crimping stresses the metal. Okay, so this is about the contractors' most important things. Use only the top parts, especially in electrical. Use only the very top quality parts. Snyder for me is only Snyder. I only use Snyder. Okay, wires must be joined properly. Use the top quality wire, which is in Sarawak is UC cable. Okay. Okay, so any questions? Anyone, any questions? Okay, let me. So since okay, since there are no question, let me just refresh the main points in electrical construction. Don't ever do this. Okay, this is 2 computer labs in Swinburne was burned because of this. You see, the neutral wire, when you do like this and you crimp and you tape, it's wrong. Why is it wrong? When you crimp, you're stressing the metal. Mechanical engineers will tell you when they get a sheet of metal, they bomb and make it a bonnet. They need to heat it at 500 degrees centigrade for 24 hours. So what is this? You're crimping and then tape, which is a lot of contractors doing this, is totally wrong. Okay. What I do, I strip 3 inch, like that. I blow the blowtorch here and drop the solder here. You cannot blow the whole wire. I tried already because the copper turned the copper oxide. The solder doesn't stick to it. You just blow the end and and then when it cool down a little bit, you cut off the end because the end is sharp anyway. Okay, put it down, tape. Only 3M tape. Don't use any other tape. 3M. Okay. 3M. That's a good tape. And then wires, stick to UC lah. UC cable is a Sarawak company. Is a top quality lah. You can see, I can see the difference. Once I see a cable, I know this UC or not UC. Okay, it's just more copper. If you see a bit black, means it's too much iron inside there. Okay, and then you see the whole cable load is very light. That means it is aluminum plated with copper. Okay, so these are the big dangers in electrical right now lah, in construction practices. Use only the very top quality Schneider for me. I mean, some people use Hager, but I rather use Schneider because Schneider is number 4 in the world in terms of electric component suppliers. Is number 4. Number 1 is GE, number 2 Siemens, number 3 is ABB, and number 4 is Schneider. The rest are down. Hager is way down there. Okay, a lot of contractors in Sarawak like Hager, but I only use Schneider. Okay. So, any other questions? Okay, remember, solder all joints, tape properly. Okay, don't try to save on tape. Tape properly with the best tape, which is 3M tape. And I mean, you must understand the whole system lah, from Bakun going down to Sarawak. Why you have to step up and step down? You know, transformer is because of, you know, when you step it up, the current goes down, so you can use thin wires to transmit. Okay. Still no questions? Let me see other things, important things. Get tools, only the very best tools, huh? Oh, you can use the microphone to ask me, and you can chat in the chat room also. Okay. What that? Okay. Anything that's not clear? Okay, so tools, only the very best tools, huh? Don't waste your time on alang-alang tools. I get my brand, MTC is a very good brand. MTC, Malaysia, Thailand, China. Okay. And all best tools, like even my simple pliers, like 40 ringgit, 80 ringgit pliers I have. Screwdriver, like 28 ringgit, 30 ringgit. You know, once you get a good tool, you use it for the rest of your life. You never need to change it. My wire stripper 10 years ago is still cutting perfectly. Okay. I just did a very high voltage job recently, and I'm still using that 10 years old wire stripper. Okay. So once you get a good tool, you use it for the rest of your life. So, okay. So still no questions? Those of you who want to be going to power, I highly recommend. Not so much in electronics, because I think electronics have moved to China mostly. Okay, so power is what is coming up in Sarawak, because we are building a lot of dams. We need to build dams because that's our advantage, water. Okay, so we have to utilize all our resources. You know, it's just like you're given gold, you don't want to use the gold. You know, gold. I mean, water is our goal. Okay, I fully support the dam because I work in Cisco, and nothing compares to the dam. Okay, they are so efficient. Everything is good about them. I can't find anything bad about them. It starts up in just 20 seconds. You can call up Batang Ai. At the time it's only Batang Ai. I call Batang Ai. Can you give me power? They give me in 20 seconds. I call up other power stations, 8 hours. Okay, 8 hours for coal. And then we are finding. Sorry. How do we assess the information for the component when we are finding Why, it is a very hard English to understand, to decipher. Oh, information component, just type in Google. Just type the proper name, ID, and the part number in Google, straight away everything comes out. Normally Google is the best resource. Contractors use Google, They go to some site, they're supposed to, the sites are supposed to keep the manual books, but nobody keeps their manual books. And repairers need the manual book to know what's going on. So what we do, we just go to Google, type, and get all the information there. Okay, data sheets. Okay. Okay. Okay, so if there's no questions, I will close the webinar now. So there's one other question. Okay, here. Usually, how many options should a contractor prepare for a work? Options. No, you got to design a perfect solution. Okay, this is a question asked by someone. Usually, how many options should a contractor prepare for a work or equipment request? Okay, the job order is called work order. Okay, you have to find the best design. You cannot have two options. You need to find the best solution. Okay, you cannot have two options. But of course, when you go to site, sometimes there might be some things that happen. Then okay, quickly redesign. But because you already work on one design very carefully, so to change a bit is not so hard. Okay, you got to work very clearly on exactly what you're going to do. But when you go to site and the customer maybe requests a slight change, it will be easy because you already have a detail of the original plan. So modifying original plan is not so hard. Okay. How to be a certified to do electric work? Okay. IR, you cannot do work. Okay. To do work, you need wireman chargeman. I also thought after my degree I got an IR. Okay, I call Board of Engineer Malaysia. Okay, now I got IR, I can do work, right? No, you cannot. You got to get wireman. The driving license of your car is driving license, right? For electrical is wireman chargeman. So that's why I got quite a lot of wireman chargeman right now. I'm mostly chargeman. Okay. So I took quite a few, so I can do most of the jobs. I cannot do the very high voltage ones. I'm trying to upgrade to those right now. Okay. But even in IR, it's not the end of the story, IR, there's 3 more levels after that. There's a supervisory engineer, competent engineer, which is what I am, and then the last one is ESE. Officially, there's no ESE in Sarawak, but there are 2 who are recognized as ESE, Lau Wen Ho and Henry Fong. Okay, a lot of Chinese call them Chap Bei Liao. Okay, they are so rich. Okay. Basically, the 4 factories in Samalaju pay them 70,000 a month just to stand by. Okay, and then practically every other projects in Sarawak, their name is there lah. Okay, so wireman chargeman very critical lah. You must because those are actually doing hands-on. Okay, exams. So you basically it's a 2.5 hour theory, another 2 hours of electric law, and then about 5 hours of practical. You must get through that. Then you're certified wireman, and then after you upgrade to chargeman, and there's so many levels. Like about over 30 different certifications in electrical, whereas in mechanical it's just 4: boilerman 1, boilerman 2, and then the engineer level another 2 boilermen. Civil there's none. So electrical has the more certification because there's more danger. There's so many people dying because they don't understand the systems. You must understand clearly a system, then you don't die. Okay, the people I know, super experts, they don't get even a small accident. Okay. Anyone above 18, no qualification required. You fail Form 5, fail Form 3, no problem. As long as you can read and write BM and English, you can get wireman and chargeman. Okay, but you need experience. You need to work for some electrical people lah. That's the best way. So the best way is for you as students, go to a contractor lah. They are the one who do the most work. Okay, once you get the skill outside, I think contractor is the best job. They really do the work. Or construction, Cisco building dams, Ballet Dam. They're right now building. They're looking for people. They are one doing work. Even though you're Cisco staff, you're really doing work. That's internationally recognized. Once you do work, people can see. You know, interview they can really catch you. Don't you cannot pretend. This skills all it's just with you somehow. Interviewer can somehow know. I got one guy, my student in Cebu. He just passed. He's very good in practical because he did the diploma and then he went to work and then come back to the university. But anytime you go to an interview, the boss will say, "Okay, tomorrow start." Oh, they know this guy. Boleh pakai, you know, he can make money for us. Okay, so that's the best thing lah. Certified to do electrical work. Okay, the license is all given by EIU, EIU Electrical Inspectorate Unit. Okay, we have a separate unit like that in Sarawak. Okay, because we got two laws different from Sarawak and Semenanjung. Our electric law is different from Semenanjung, and our labor law is different. So that's why we have a department called EIU in Sarawak. In Semenanjung and Sabah, they use Suruhanjaya Tenaga. So our certs cannot be used in Semenanjung and Sabah, and their certs cannot be used in Sarawak. But they can upgrade. Because once we know electrical is worldwide recognized. People interview you, you know the basics, the real electrical, the hands-on electrical, worldwide is the same. I got one student who has no qualification, just Form 5, and then he got chargeman. I taught him, and he got chargeman. Oh, now he is super worldwide. He is international, making tons of money. Okay, because anyone in the world can recognize, oh, you know that one, okay, I take you in. You know, the practical side of electrical, because the wireman chargeman is not really like university. University, they do a lot of calculations we sometimes don't use. You know, actually most of the time don't use lah. But the wireman chargeman, they really teach you what you really need for practical side. Okay, and this is internationally recognized. Not necessarily the Sarawak cert is recognized. What you say is recognized. Okay, but you have the cert, and then you can say the correct things. This is, you know, international people will just take you. Okay. So for me, I have IR, computer engineer, and then chargeman, L1, L2, H2, EIC, ATT. Okay, quite a lot of certificates lah. Okay, and then computer engineer also you can upgrade, which I plan to do. Go to right now I've only LV. Plus 11 kV, but I plan to upgrade it to higher voltage lah. Every voltage you need to get a cert. Okay, it's all by experience lah. You know, some people try to, you know, jump steps, you know, jump here and there. There's no excuse out of learning the thing lah by practical. Okay, learning the real theory, the real things they're using, not some calculation here and there. The real thing that's used outside, which is a lot. You know, that's what I teach in my university, because all other lecturers giving calculation, I give theory, because that's what you need when you go outside. Okay, that's what the employees are looking for. Okay, so I said, okay, let other lecturers teach you maths, I teach you engineering. Okay. Okay, so if no questions, okay, I'll just close the webinar now.
Hello everyone, thank you for attending this webinar. For anyone that would like to know more about chargeman, you can apply for it anytime during the semester breaks, anytime you want. You'll need a cert for this, so you need to apply for it. So any other questions you can ask me or any of the VOC for this group, which is Ching Yu Yan and Ko Hui Ting, they will get to Dr. Prashobh. So any other questions you have outside of this webinar, you can get to us. So I guess that's all for this webinar today. Thank you for attending. All right, bye-bye.
Remember to fill the form, yeah, guys and girls.
Leave.